Hey guys, so we're doing the flow testing and wanted to just try something I've never done before, and I thought you guys might enjoy the test itself. We are going to test some spacers. Alright, we're gonna look at an AFR 1-inch spacer. So this is a plastic 1-inch spacer. Taper, 4-hole tapered spacer. All these are 4-hole tapered spacers. This one is $47. Stepping up, this is the Super Sucker HVH 2-inch. So it's got a nice machined 4-hole taper here. Okay. Then we're stepping up to Wilson manifolds. Very popular. Supposedly the best on the market. Certainly the most expensive. These are billet CNC machined. They certainly look nice. That's the 1-inch, and this is the 2-inch. And these are the more expensive versions, which are the lighter weight. I do like how this taper goes all the way down on the Wilson. This is like a fuel shear here. And how the middle divider goes all the way down versus the Super Sucker, which the taper kind of ends 1 inch down. Almost like they have the same program for their 1-inch versus their 2-inch. I suspect that they actually use the same program, CNC program, for both their 1-inch and their 2-inch, if I had to guess. Alright. The AFR is $47. The HVH Super Sucker is $151. Like I said, it's a middle ground, cheapest middle ground. And the two most expensive, $216 for this 1-inch and $276 for the 2-inch. So if you're spending that kind of money, you want it to perform. So save your money. I'm gonna test it. Let's see what happens. All right, and make sure we verify. Sit that down here for a second. We're going to test them all in 50 thousandths increments, from 50 thousandths all the way to 650 thousandths. So this is going to get us a very good idea of what they all flow. Okay? I will get with you shortly. First up is going to be the AFR plastic 1-inch spacer. So there's not much you can see there. Alright. I'm going to set the phone down and do the flow test and get back. Alright, AFR is done. Next up, Wilson manifolds 1-inch. Like I said, not much you can see there. How the taper is. what's next. Next up, the Super Sucker, the HVH. I'll get the flashlight, but again, there's not going to be much you can see. Just the camera wants to focus on the closest thing. All right, here we go. All right, last up is the 2-inch Wilson spacer. This is the most expensive spacer, but let me show you something. I don't know if I'm going to get a good accurate test with this. This spacer is, believe it or not, warped from the factory. You see that daylight there? It will not sit on the carb pad. In fact, all of my bolts are kind of bowed inwards. And I actually gouged my ARP studs trying to force my carb on there to get this test done for you guys. I am very unimpressed with the workmanship here, believe it or not. All right, I will try to seal that up the best I can and run the test. Okay, so before I do this test, I want to show you something. So I got those tight, but keep in mind something. For those of you who say, oh, well, the Wilson's tapered spacer is supposed to be that torqued so that when you torque the bolts down, it's nice and snug. I don't think, and I don't know if you'll be able to see it or not. Let me see if I can do this. There we go. And zoom in a little bit. And let's see if we can focus that. You see that overhang right there? I don't think that they meant for that to overhang. So this is a dud and would be going back to Summit if I were buying this to run it, which I would have had it flowed more, which I haven't flowed it yet. So if it does flow more, even in this state, then I will definitely get another one and hope it's better. Certainly looks cool. Let's see if it flows good. Okay, so I'm done flow testing. I also did a flow test with just the throttle body by itself. So these numbers don't mean anything to you. I got to do the math, but these are the delta P's. This is the throttle body by itself, and then I flowed it with my methanol plate, which is a 5/8 inch plate, and open plate, and it did nothing to flow, so it doesn't improve it or make it worse. So this is our baseline, and this is what we'll compare it to. I'll come back when I have the math done. All right, the test is done. Before we get to the numbers, I want to make sure I make it clear that this test is not a test of these spacers on a dyno under dynamic conditions in the engine, metering fuel, changing anything else. This is purely a change in airflow on a flow bench. Okay, we are testing them on the flow bench at 28 inches of water and comparing it to throttle body by itself and the spacers individually. No other conditions change. This is purely a CFM test. So I want to make sure that's clear, that maybe they do something better when they're on the running engine. Maybe they don't. But let's look at what the change in flow was using these different spacers, and you'll find them interesting, I think. All right, so this is the throttle body by itself, the CFM at each one of these lift values, okay? This is port number 5, which flowed less than the outside runner. This is the one I'm trying to improve, and the whole reason I wanted to try the spacers is to see if I could improve the flow dynamics there. The short answer is no, I cannot. All of these spacers do nothing for flow. So let's look at it specifically. So this net delta basically is just taking and adding up all the CFM gains throughout the sweep and subtracting the losses, okay? So we had, basically that worked out to be no gain, if you look at it in this way. The real truth is below 250 thousandths lift, it picked up a couple CFM. And then in the mid lift, where this lift doesn't really matter, the cylinder or the piston's barely traveling down the cylinder at this lift value. So that's why I don't really test below 200 thousandths lift, because the piston's not even really drawing in much air. Most of this is just to evacuate the cylinder on overlap. So it's not really contributing to flow. This is where flow starts picking up, and the mid lift here in the 3 to 500 thousandths is where the most important bang for the buck is. If there's any kind of gains, that's where it's going to be, especially with my camshaft, and I'm going to do another video showing that and what I mean by area under the curve and why mid-lift flow. You hear that mid-lift flow means more than peak flow, and I'm going to prove that in my next video that I'm going to make, or one of the next videos. So the Wilson 1-inch, which is $216, and the mid-lift was down. Everywhere else it didn't improve. So that one is a loser. The number 2-inch Wilson, which is the $276 spacer, which is the most expensive spacer. Other than the fact the one I got was a little defective and I had to kind of force it flat on my throttle body, and it looks like the machining might have been off a little bit, so that might have affected some of these numbers. But that was the biggest loser of all. It did nothing but lose flow everywhere. And the most important area, the 3, 4, 500 lifts, it was down a lot of flow. So the net delta is a minus 43 CFM throughout the sweep. The AFR, of any of them, the cheapest one at $47, it actually had a net delta of 9, a positive CFM, which of all of these, it was the winner. However, if you look at where it gained most of that flow, was below 200 thousandths lift. So this spacer would have helped evacuate the cylinder better. But in the 3, 4, 500 lift values, it was down 1, up 1, down 1. So yeah, actually didn't help at all. And everywhere else, the flow was the same. The HVH, which was the Super Sucker 2-inch spacer, was the second worst. Again, below 200 thousandths, it gained 1, 2, and then it was down everywhere, with the biggest loss being right here in the mid-lift. So interesting results. I think some of the explanation that I can come up with the 2 inches being so bad is on a flow test you are introducing additional restriction, so the air is going a longer path before it goes into the plenum, and I think that the friction in the air, that this taper that's there is not doing anything at all. It might, in a carburetor that needs signal, this may speed up the air a little bit. I don't know. I didn't really see that. That was not witnessed by me. This one, also bad. Didn't really see anything special out of that one. This one, also bad. Didn't see anything special out of this one. Super pretty though. And the cheap one that doesn't look cool at all, it doesn't even look like it would work good, was the best. And at the end of the day, none of these will end up on my engine because one, in order for me to run one of these, I would need to run a cowl, and I wouldn't be able to fit it under the factory hood. But if it was to, I would have done that if it was to improve flow. It did not. And for the record, my 5/8 inch thick methanol injector plate did not affect flow at all. It didn't lower it. It didn't make it any better. It just, so it's gonna run just like this. I'm not gonna use one of the spacers, and again, this is just my test on my cylinder head and my manifold. Maybe you'll experience something different. Maybe they do something when you're at power, but none of these are gonna make it on my engine. So you decide for yourself. I'm gonna continue working on the manifold and start getting it completed so that I can work on the other cylinder head and the other side of the manifold, and develop each one of these independently. And I might do another video once if I discover anything else that I think is worth sharing, and then I will do a video when it's completely done so you can just kind of see what the work looks like. And then yeah, we'll start engine. I'm ready to get it together. So that's it. See ya. And Semper Fi for all my Marine brothers out there. Kill.